Bus voltage regulation is commonly accomplished via load tap changing transformers, which allow the output voltage of a transformer to be regulated, typically in 32 discrete steps, with each step representing 5/8% change in voltage. The objective for implementing LTC control is to hold voltage at a bus at a desired level. For example, consider the simulation results from this sample network where voltage drop at the terminal of the loads is above 5%. We can define LTC control settings at the upstream transformer in order to control voltage at bus 5. However, rather than guessing or iteratively going through all 32 steps to figure out the proper tap setting, OpenDSS can solve the optimal tap setting for us. Let's see how we can do this at the upstream transformer here. Let's go to our one-line edit view to implement the LTC control. We will need to turn on the feature and then define the settings. First, we need to select the bus we wish to control voltage at. A pick list of buses available for control is provided, and once you have selected one, you'll need to provide the regulator voltage, which defaults to 120 volts, bandwidth, and PT ratio. The PT ratio can be manually entered, or you can click on the calculator to have one calculated for you. You might be wondering what bandwidth is all about. Well, due to the step change nature of the LTC output, you'll need to provide a bandwidth, which is essentially a range of voltage which is acceptable and can be considered in band. This is expressed in volts on the 120 volt base, and 1/2 of the bandwidth is allowed for above and 1/2 for below the voltage level setting. In the example here, we're setting the LTC to control voltage at bus 5 to 480 volts. And we'll keep all the settings as is for now. Let's click Save and notice how the transformer symbol has changed to indicate LTC control capability. Let's save our one line and perform a power flow simulation to see bus voltage regulation results and the recommended tap settings. Note how voltage drop at our loads are around 5% or less, and voltage drop at bus 5 is pretty much negligible. Well, you should now have a good handle on how to implement LTC control on 3-phase 2-winding transformers. So this concludes our brief tutorial on this feature.